Hello students, today in this video we will see how to trace a curve, the equation of which is given in parametric form. The equations of the type x is some function of t, that is f of t, and y is some another function g of t. It is known as the equations in parametric form. Let us see the rules to trace the curve given by parametric equations. The first point comes the symmetry. Now if x is f of t, this is an even function, that is f of minus t is equal to f of t, and y is equal to g of t. It is an odd function, that is g of minus t is equal to minus g of t. Then the curve is symmetrical about the x-axis. Okay, we can see an example. This is the parabola, the parametric equations of which are x is equal to at square and y is equal to 2at. Now this x, it is an even function, and y, it is an odd function. Because if we replace t by minus t, x will remain unchanged but y will change. We can see from the figure, the parabola, it is symmetric about the x-axis. The second one, if x is equal to f of t, it is an odd function, and y is equal to g of t is an even function. Then the curve is symmetrical about the y-axis. Example, again this parabola, the parametric equations of which are x is equal to 2at and y is equal to at square. If we replace t by minus t, the value of x will change but that of y will remain unchanged. The given parabola, that is this curve, it is symmetric about the y-axis because this y, it is an even function, x is an odd function. The next, if x is equal to f of t and y is equal to g of t, both are odd functions, then the curve is symmetric in opposite quadrants. We can see this is a hyperbola, the parametric equation of which is x is equal to c of t and y is equal to c upon t. If we replace t by minus t, both will have a negative value, and hence we say that the curve, it is symmetric in opposite quadrants. Next, for values of t and minus t, x remains unchanged, but y has equal and opposite values, then the curve is symmetrical about the x-axis. Same, it is x is equal to at square, y is equal to 2at. We have seen it. Another point, replace t by pi minus t. If y has same value and x has equal and opposite value, then the curve is symmetrical about y-axis. We can see with an example, x is equal to a cos cube of t and y is equal to a sin cube of t. If we replace t by minus t, what we'll have here, we'll have the opposite value. It will be minus a cos cube of t. But here if we replace t by minus t, the value remains same. So we can say that the given curve, it is symmetrical about the y-axis. Then next comes the whether the curve passes through the origin or not. How to find it? If for some value of t, both x and y are 0, then the curve passes through the origin. That is, we can find out, put x is equal to 0 in the equation of the curve and find the value of t. Then substitute this value of t in y. With this value of t, if we get y is equal to 0, then we can say that the curve passes through the origin. The next point, tangents at special point, that is dy by dx. Okay, we have to find dy by dx as it will be dy by dt upon dx by dt, and then we have to prepare a table of the values of t, x, y and dy by dx. The nature of tangents. Now if the value of dy by dx at the point t, it is 0, then we can say that the curve has a tangent parallel to x-axis at that value of t. And if dy by dx at the point t, it is equal to infinity, then the curve has the tangent parallel to y-axis at that value of t. In this way we can find out the nature of tangents. And last comes the points of intersection. Now we have to find a value of t for which x is not equal to 0 and y is equal to 0. So that we'll get the x intersection, that is where the curve intersects the x-axis. Similarly, you have to find the value of t for which x is equal to 0 and y is not equal to 0, so that we'll get the y-axis intersection. We'll solve a few examples in the coming videos so that all these points will be clear. Thank you.